All right, this is the early angle pairs notes or practice. So we had all our definitions, and now we're going to kind of use those definitions to go through different problems. So the first thing we had, it wasn't one of our official definitions, but it was in there and we wrote it on the side of our notes, and that is adjacent. Adjacent means next to. So two angles that are next to each other are going to share an entire side, and the side of an angle is a ray. So if we look at these, we have angle BAC, which is right here. And we have angle CAD. Okay, and if we notice, this ray AC is part of both angles. So it's entirely part of both angles. So we would say, yes, these two angles are adjacent. They're right next to each other. They share a side. They share a ray. All right, the next one, angle EFG. Okay, remember, angles are made of two rays, and rays go on forever. They don't stop. Even if the diagram stops, that doesn't mean the actual angles or the rays making up the angles stop. So if we're looking at the second one, our two angles share part of a side, right? They share part of a side, but they don't share the entire side because those sides really go on forever. So since they don't share an entire side, this one's going to be no. These angles are not adjacent to each other. All right, and the third one, we have angle J and M at the top here. And then we have angle L and K. Whoops. L and K right here. Okay, they share a point N, right? They share a vertex, a point N, but they don't share an entire side. So again, we would say no, they're not adjacent. Adjacent, they're right up next to each other. They share an entire side. All right, the next part is complementary and supplementary. So complementary angles are angles that add up to 90 degrees. Right? Complementary angles add up to 90 degrees. So to find the complement of 52 degrees, we need to subtract from 90. 90 minus 52 is going to give us 38. All right, so 38 plus 52 adds up to 90 degrees. Okay, two angles that add up to 90 degrees are complementary. All right, so then this one would be 14. Right, 14 plus 14 is going to give me 90. And then over here, 19 plus 71 is going to give me 90. Okay, so complementary means they add up to 90 degrees. Supplementary means they add up to 180 degrees. So we have two angles here. If angle 1 is 52, 180 minus 52 is 128. So 52 plus 128 equals 180. That's what makes them supplementary. They add up to 180. So over here, we would want to have 104. Right, 76 plus 104 equals 180. And then over here, we would have 161. 19 plus 161 is going to be 180 degrees. So complementary angles, it could be two or more, add up to 90. Supplementary, add up to 180. All right, vertical angles. So I'm going to draw a little diagram here. Let's see if we can't get two lines so it's perfect. Awesome. And then I'm going to draw on this. Okay, vertical angles. Let's start with vertical. Okay, so if you have two lines intersecting, basically the ones that are opposite each other are going to be vertical. These would be vertical to each other. They're across from one another. So officially your definition is two non-adjacent angles that have that are formed by two lines that intersect, right? So basically you have an X that forms when two lines intersect, and then the ones that are across from each other. Right? So that would be an example of vertical angles. Linear pairs would be adjacent, right up next to each other. So Linear pairs are supplementary and adjacent. So an example of a linear pair is these two angles. If I called this angle 1 and this angle 2, right, they're going to form that straight line. Because remember, linear, right, the first 4 letters are line. So they form a straight line. And they're adjacent, they're right up next to each other. Okay. So let's look at our diagram. All right, 1 and 2. So here's angle 1 and 2. If you add them together, they're going to form that straight line 180 degrees. Plus, they have a shared side, so they're adjacent. So since they're adjacent and supplementary, they're going to be a linear pair. Linear pair. Okay, they form a straight line. All right, 1 and 3. So they have a common vertex. They're formed by 2 lines intersecting, and they're across from each other. So that's going to be vertical. All right, 1 and 4. So 1 and 4 form a straight line. Okay, 1 and 4 are supplementary. They form that straight line, and they're right up next to each other. They have a shared side, so they're adjacent. So that's going to be a linear pair. So let me type these in as we go. We had linear pair. We had vertical. And we have vertical. Okay. All right. 1 and 5. All right. Here's angle 1. Here's angle 5. They have different vertexes. They have different intersection points. So they can't be vertical or linear because vertical linears are formed when 2 lines intersect, and linear pairs are right up against each other. So this has to be neither. Okay. I'm just going to put an N for neither. Okay, the next one, 1 and 6. So again, we're looking at 1 and then 6. So again, they are different intersections. This one should be neither. Okay. 1 and 7, different intersections. This one should be neither. They have to share the same endpoint, the same vertex, right, and be across from each other. 1 and 8 is going to suffer from the same problem. They're not at the same intersection, so that one's neither. Okay, but 2 and 4, right? You have 2 lines intersecting. You have 2 and 4 on opposite sides, across from each other. That one is going to be vertical. All right. Let's look at the next section. All right, the next section here, we can write an equation. Okay, but let's first look at this. Okay, a straight angle is 180 degrees. So these 3 angles here are going to add up to 180. This is the right angle symbol. So if I subtract 180 from 90, I'm going to get 90. 180 minus 90 is 90. Which means that these 2 angles are also going to add up to 90, right? If all 3 of them add up to 180, then these 2 are going to add up to 90. Let me draw a better right angle here. Okay, which means the equation I'm going to set up here is going to add those 2 angles together and set them equal to 90. So a measure of angle ABD plus measure of angle DBC equals 90. We just created an equation, so we need to justify it. So my justification is going to be complementary. They're complementary angles. Complementary angles add up to 90 degrees. I can then substitute in my values. So I have 2x plus 3x equals 90. That's 5x equals 90. That's going to be x equals 18. If I want to find the value of the 2 measures of ABD and DBC, I need to substitute it in. So 2 times 18 is going to give me 36. And then 3 times 18 is going to give me 54. That means the measure of angle ABD is 36 degrees. The measure of angle DBC is 54 degrees. And again, 36 plus 54 adds up to 90. So we know our answer is correct. Okay, these are a linear pair. They add up to 180. They form that straight line. So our equation that we're going to put together for this one is going to be the measure of angle ABD plus the measure of angle DBC equals 180. Okay, our justification why that's true, we could either do linear pair or we could say they're supplementary angles. Okay, both those justifications are fine. And then we substitute in. So for measure of angle ABD, I had 4x plus 6 plus 11x minus 6 equals 180. Combine like terms, so that's going to be 15x plus 6 minus 6. Those cancel. So it's just going to be 15x equals 180. And then when I divide by 15 on both sides, that should give me x equals 12. Substitute in, just in case, we want to check our answer and because they're asking for it. So the first one, 4 times 12 plus 6 is going to be 48 plus 6 is 54. Then the second one, we have 11 times 12, that's 132. Minus 6 is 126. And 126 plus 54, they add up to 180. So we know our answer is correct. 54 plus 126 is 180. Okay, 22 you would do the same way as 21. These are a linear pair, so they would add up to 180 degrees. You'd have to write your equation out, justify your equation, and then solve. Right, the next two here. Same thing, they're telling us the first first situation, they're complementary. Second situation, they are supplementary. So if they're complementary, the measure of angle A plus the measure of angle B is going to equal 90 degrees. Our justification is that they are complementary. So the reason our equation works, complementary angles. And we can once we have the equation and the justification, we can substitute in and solve. We have 4x minus 2 plus 11x plus 17 equals 90. So if I combine like terms, I'm going to have 15x minus or plus 15. Subtract 15 on both sides. I get 15x equals 75. Divide by 15, I get x equals 5. If I want to check my answer, I can substitute them in, right? So I can do 4 times 5 minus 2 is 18. 11 times 5 is 55 plus 17 is 72. 72 plus 18 adds up to 90. We know our answer is good. Those two angles add up to 90. Next one, what if they're supplementary instead of complementary? Well, if they're supplementary, they're going to add up to 180. So measure of angle A plus measure of angle B equals 180. So we're going to do 4x minus 2 plus 11x plus 17 equals 180. Combine like terms. Oh, we got to justify. We didn't justify our equation, so we got to make sure we justify it. So the reason this equation works is because they're supplementary. Supplementary angles add up to 180. So combine like terms, I'm going to have 15x plus 15. This time, though, instead of equals 90, it's going to equal 180. Subtract 15, I get 15x. Whoops, that should be 180. That's 165. Divide by 15 and you get x equals 11. We want to check our answer. 4 times 11 minus 2 gives us 42. 11 times 11 is 121 plus 17 is 138. 138 plus 42 adds up to 180. So we know our answer is good. All right, complementary, again, add up to 90. So the ones that are going to add up to 90, you could do 1 and 2, or we could do 3 and 4. So remember, since this is 90, all three of these are going to add up to 180. So 180 minus 90 is 90. So we don't know what 1 and 2 are, but we do know they're going to have to add up to 90, which makes them complementary angles. Same thing for 3 and 4. The whole straight line is 180. Subtract the 90 that we have here. That means that these two have to also add up to 90. Supplementary. So anything that forms a straight line here. So you could do 5 and 6. You could do 7 and 8. You could do 5 and 8 or 6 and 7. Okay, vertical are across from each other when two lines intersect. So you could do 5 and 7 are vertical, or 8 and 6 are vertical. Okay, linear pairs are supplementary angles that are adjacent. So let's just look at our supplementary ones, 5 and 6. Do 5 and 6 share a common side? Yes, they do. So 5 and 6 are also a linear pair. Same thing, 7 and 8. They share a common side, so they're also a linear pair. So I can leave 7 and 8 as well. And then linear means supplementary and adjacent. So if they're linear, you know they're already going to be adjacent. Okay. You could have also done 1 and 2 or 3 and 4 for adjacent as well. You could have also done 1 and 2, 3 and 4. All right, just a few more here. Vertical, linear, or neither. Okay, so 1 and 2 are going to add up to that straight line. So those are a linear pair. All right, 1 and 3, two lines intersect. They're across from each other, so that's going to be vertical. Okay, 2 and 4. A lot of people want to say vertical, but they are neither. So if we look at this, so we look at angle 2. Oops. All right, the vertical one for angle 2 would be 4 and 5 put together. So it's not just 4. It would be the measure of angle 4 plus measure of angle 5 would be vertical with 2. So this one has to be neither. All right, and then 34. 4 and 5, right? They're adjacent, but they don't add up to a straight line. So this one, again, is going to be neither. 6 and 8, those are vertical, right? You have two lines intersecting. They're across from each other. So 6 and 8 are vertical. 8 and 9 are right next to each other. They're adjacent, and they form that straight line. So they're a linear pair. 10 and 11 are right next to each other, and they form a straight line. So they are also a linear pair. And then 10 and 7, they do not share an entire side. They share part of a side, but remember, both of these go on forever. So this one is neither as well. All right, and then the last one I want to do, we'll skip these for now, 39 and 40. You can ask in class if you have questions on those, but let's look at 41 and 42. So these are vertical angles. Okay, vertical angles are congruent. So we should have that written on our notes, but vertical angles are congruent, which means they have the same measure. So we can set them equal to each other. So we can do 105 equals 2x minus 11. We need to justify our equation. So the justification is that they are vertical angles. Vertical angles are congruent. Okay, if we want to solve, we're going to add 11 to both sides. That's going to give me 116 equals 2x. divide by 2 on both sides, and we get 58 equals x. So if we substitute that in, 2 times 58 minus 11, that should give us 105. Okay. To find the other angles, these are vertical, so they're equal. These angles form a straight line. They're a linear pair. So if we do 180 minus 105, we're going to get 75. That means this angle has to be 75. And then vertical to that one has to also be 75. So we have 75, 75, 105, and 105. Same thing here with 42. It's pointing to this angle right here. So these are vertical. So we can do 8n equals 9n minus 5. I can subtract 9n from both sides, which gives me negative n equals negative 5. And if I multiply both sides by negative 1, I get n equals 5. We needed to justify our equation. Our equation is justified because those two angles are vertical, and vertical angles are congruent. Their measures are equal. So now we can substitute in. 8 times 5 is 40. Right? Which means the other one across from it should also be 40. So if we plug it in, that's 45 minus 5, which is 40 when we're good. To get the other ones, those are linear pairs. So we do 180 minus 40, which is 140 degrees. And then the one across from it should also be 140 degrees. And that's it for the complementary, supplementary, vertical, and linear notes.